Hey guys, now let's look at this question 3C of paper 2007. So it has this kind of a graph, and actually about this graph it gives us the basic information about this photocell. We already know the mechanism of it. Okay, now we want to read this graph of EK and F. We are looking at this graph. EK is going to be equal to E photon minus phi. It is going to be HF minus phi. And since we know that H is a constant and phi is a constant, this equation is actually about the relation between EK and F. So that's why we have y-axis like maximum kinetic energy EV, which is also EK max. And on our x-axis we've got this frequency. Okay, so from the graph determine the threshold frequency of zinc. Now we can read it already from this graph. Then let's zoom in a little bit, make it bigger, so we can read the number here, the value here. So this is 1. This is 1.5. So this is going to be 1.1, 1.2, 1.3, 1.4, 1. So this is going to be 1.1, and this intercept here. Now let's read it like 1.05. So it is going to be actually 1.05 times 10 to the power of 15 hertz. Don't forget that, all right? So we can write it here. 1.05 times 10 to the power of 15 hertz. And then maybe let's try to deal with this question D. The equation for maximum kinetic energy of the released electrons in joules is EK. We know it already. Using information from the graph, calculate a value for Planck's constant to show your working. We want to know. We want to calculate this time this H thing, the constant, Planck's constant. So how do we do that? We want to make sure that EK is 0. EK is 0, so that we have H times F minus phi is going to be 0. So we have H. Now this time it is not asking about the frequency. It is asking about the Planck's constant H. So it is going to be like phi over F. And now this F is not a random F. It is going to be the threshold frequency. Now the threshold frequency on this graph is going to be, the x-intercept. So it is going to be 1.05 times 10 to the power of 15. And the phi here, let's read it a little bit. Phi, now this negative 4, something is going to be our negative phi. So for phi, we can read it. We can zoom in here. Maybe that's too much. Yeah, let's read this. Okay, so we have. So this is going to be like 1, 2, 3, 4, 5. So 5 grids, 5 segments. 5 segments is going to be negative 2. We can, just calculate the length of it. So it's going to be 2. So one segment is going to be 0.4. So that means that this is 0.4, right? So this is half of half of 0.4. So it's going to be like a 0.2. So I think this y-intercept is going to be negative 4.2. So this is going to be negative 5. So phi is going to be 4 times 2. Sorry, 4.2 times. Now this is actually this is in the unit of electrovolts. We want to convert it into like international units. It's going to be 1.6 times 10 to the power of negative 19, and then we use our calculator. 6. Let's let's move it here. So it is going to be, wait, what? 4.2. 4.2 times 10 to, sorry, it should be 1.6 times 10 to the power of negative 19 over 1.05. 1.05 times 10 to the power of 15, if I'm not mistaken. It's going to be 6.4 times 10 to the power of negative 34. So it is 6.4 times 10 to the power of negative 34. It is a constant, so we don't have to write the show your working value for. Actually, we can give it a kind of unit, right? Because we know phi is kind of energy, so it has a unit of joule, and the F is kind of frequency, and it has the units of hertz. So actually, for Planck's constant, we can derive its unit too. It is going to be joule per hertz. And we also know that 1 hertz is going to be 1 over 1 second. So it is going to be this 1 over 1 hertz is going to be equal to 1 second. So we can say Planck's constant is 6.4 times 10 to the power of negative 34 joule second, or joule per hertz. I think both are okay. All right. So questions C and